back to another day of the Math Dojo. We are here today talking about the real number system. We've been working from home. Hopefully you guys have been working from home. I actually had a movie playing in the background right now, and I haven't seen the whole Endgame, the Avengers Endgame yet. I've seen it like 5 times, but I've never seen the ending. But anyways, now I've seen the ending and it was really sad. So we're going to be talking about the real number system. The reason why we need to know these different numbers and where they belong, and well, for a lot of reasons, but the main reason it's going to be on your test. So they will be asking questions like, is the square root of 2 an irrational number? Or is 1.3333 a real number or an imaginary number? It's kind of cool because it does build upon each other. So yeah, let's get into it. The reason why we say real number system is because we do have 2 different number systems. You will be learning the imaginary number system. It's represented by this symbol, a little I, and you'll be learning that when you get to high school. So right now we are going to start with the category of natural numbers. Okay, so I have my notes here so I don't forget anything, and I have my whiteboard here so that you guys can take notes. So please get out a piece of paper, pause the video, go get your paper and pencil, and take notes along with me, okay? So natural numbers, the way we count naturally. So if you think about, if someone says, okay, start counting, then you will say 1, 2, 3, 4, 5, right? You won't say 1/2. 1, 1.5, 2. So the way we count naturally and the way we start counting as a kid, we start with the number 1. Okay, so natural numbers are numbers that start with 1. Okay, and every single number after that. Let's go up to 7. Okay, but any number after that, up into infinity, is a natural number. All of the categories that are going to be going on top of this natural number, it's going to include the ones from the bottom. So for example, the whole numbers, okay, whole numbers are going next. The way I think about whole numbers, when I say whole, my mouth goes like this, whole. So the O in whole, I make big for my students when we're teaching the real number system. And with whole numbers, it is all of the natural numbers, but we're also going to now include the number 0. Okay, so it doesn't have any numbers before that. It just starts with 0 and it continues counting whole numbers. Okay, and again, we'll go to 7, but it goes all the way to infinity. Just whole numbers include 0. Natural numbers are just our counting numbers, how we start and learn to count. Okay, so I'm gonna circle these, and I'm gonna circle the natural numbers as well. So whole numbers are 0 plus the natural numbers. Okay, the next we're getting into integers. This is where we get on the left side of the number line. Okay, so I'm going to actually, okay, this is going to be, I'm going to draw the number line here so that you can kind of see. Integers are going to be all whole numbers. Okay, remember, it's including everything down, right? So it includes 0. It includes all of the whole numbers like 1, 2, 3. Let's go up to 3 this time, but it goes all the way to infinity in the positive. But we're also now going to be including the negative whole numbers. So whenever you hear your teacher say, what is an integer? Or look at this integer. Now you know what they're talking about. So they're talking about any whole number, whether it be positive or negative, but these are all integer numbers. And again, we're going to include everything because natural numbers and whole numbers are a part of integers. We're just adding the negatives now. Okay. The next one we're going to be talking about is rational numbers. And rational numbers is when we get into fractions. Okay, so a simple definition for rational numbers is just any number that can be written as a fraction. Can a whole number be written as a fraction? Yeah. Okay, so any whole number, whether you have a 1, anytime you have a whole number, you can put a 1 underneath it and it becomes a fraction. Okay, so whole numbers, 0 can be a rational number. We can have a half, okay, so 1/2 can be a rational number, or even decimals. So we can write a half as 0.5, okay, so the decimals that can be written as fractions are going to be repeating decimals, okay, so any decimals that repeat, so if we have 0.66, okay, that is going to be a rational number. And then also on the other side here, when we talk about negative numbers, are also rational numbers because they can be written as fractions as well. So we can do the same thing and have -1/2. We can have -3/4. Any number, 1,000 over 1,000,000, any number, as long as it can be written in the form of a fraction, that is called a rational number. And like I said again, repeating decimals and terminating decimals. So if we have also negative point, like the 0.5 is terminating means it stops. So 0.5 is a terminating decimal, it's a rational number. 0.66 repeating is a repeating decimal, that means it's a rational number. So if we have 0.75 or -0.75, that is a rational number as well because it terminates. It's a terminating decimal. Okay, so terminating decimals, repeating decimals, whole numbers, anything that can be written as a fraction is a rational number. I'm also going to include one more number in the rational number category, and the reason why I saved this one for last is because this number can be thought of as a rational number, and which is the next category, which is an irrational number. Any number that is not a rational number is an irrational number. All right, so like I said, there's one more rational number that we haven't covered because it's both rational and irrational, but it is pi. This looks like a big cake, actually, this drawing, but we're gonna put pi right here because that's the only place I can fit it. We express pi as 22/7. So 22/7 is a fraction, as we can see, and that is the fraction that we use for pi. So pi is considered a rational number, and it's also considered an irrational number because, as you guys know, when we first learned pi, we learned that pi is a decimal that goes on forever. Okay, so that's the example, or that is the definition of an irrational number. So an irrational number is a number that goes, or is a decimal that goes on forever. It's not a repeating decimal, it's not a terminating decimal, it's a decimal that never ends. Okay, also an irrational number cannot be written as a fraction or a simple fraction. It can't be written as a fraction. So the square root of 2, if you take the square root of 2, it is a decimal that goes on forever. It doesn't terminate, it doesn't repeat. So we're going to take the number 1.9516. That decimal is an ongoing decimal and never ends, so that is an irrational number. And then also it goes to the negative side. So a negative square root of 2, a negative square root of 5. So these are all irrational numbers. But any whole numbers, like I said, any negative whole numbers, positive whole numbers, those integers, those are all in the umbrella of the rational numbers. The irrational numbers, I'm not going to put a circle around it because irrational numbers are kind of on their own over here. It's kind of like the icing on top of the cake, right? So irrational numbers are on their own. They're not, rational numbers are not a part of irrational numbers, like natural numbers, whole numbers, and integers are a part of the rational numbers, okay? Natural numbers are whole numbers. Whole numbers are not natural numbers, but natural numbers are whole numbers. Whole numbers are integers, right? It doesn't go the opposite way. It doesn't go backwards, but it does go up the cake. All right, so this was the real number system. Like I said, we have two different number systems. We have the real number system and the imaginary number system, which we will cover in a later video. There is a question that I want to ask you, just a little quiz. Okay, so the question is, you can pause the screen, which of these numbers are irrational? And I want you to comment down below. Is it negative 4.5? Is it 3.333? Is it 0 or 1.816 repeating? Or not repeating, 1.816 continuing. So which of these numbers is irrational? Again, pause the screen, comment down below. Which of these numbers is irrational? There's only one. Okay, so I also want you to comment down below and put hashtag favorite number and tell me your favorite number. It can be an irrational number or a rational number, but my favorite number, everyone knows this about me if you know me, but my favorite number is a rational number. So I'll leave you with that, and if you can guess it, guess it down in the comments what my favorite number is, okay? And I'll tell you in the next video. Okay? But comment down below your favorite numbers. I love numbers. Of course, I'm a math teacher. I love everything about numbers. I geek out with numbers. Okay, I will see you guys later. If there's anything else that you need, please stop by the Math Dojo. There'll be more videos to come soon. Okay, thank you. Bye.